Yeah, well, there's this nice modernist Enlightenment idea that science is the way to truth, that the scientific revolution gave mankind the opportunity, of course not everybody takes it, but the opportunity to find out the truth about the universe. There's this famous couplet by the poet Alexander Pope, nature and nature's laws lay hid in night, God said let Newton be, and all was light. And people thought for a long time that science was just a question of accumulating truths, that you discovered more and more, that Newton discovered the structure of the solar system and the universe more generally, that Fresnel discovered the properties of light, that Maxwell discovered the properties of electromagnetism. It was just adding more and more, sometimes called the layer cake view of the progress of science. But then along came in the early 20th century Einstein's theory, and even more radically in a way the theory of the quantum theory, quantum mechanics, which were completely at odds with Newton's theory, in at least when one looks at them initially. And so there's this famous riposte by someone called Sir Roger Squires to the nature and nature's laws lay hid in night, God said let Newton be, and all was light. The riposte being, 'twas not to last, for devil howling ho, let Einstein be, restored the status quo. Now, part of that is based on thinking that Newton's theory was very clear and Einstein's theory is rather mysterious. That's not the case, but certainly the idea of science as a truth discovery is very a way to truth, to complete truth, is certainly challenged by the existence of revolutionary changes, so-called revolutionary changes like Einstein's from Newton's. And they really are quite radically different on the surface at any rate. So Newton's theory involves an infinite universe with action at a distance, with absolute space and absolute time. Two events are absolutely simultaneous or they're not simultaneous. Einstein's theory negates all those things. There's no action at a distance in Einstein. The world is finite but unbounded, not infinite. And two events can be simultaneous in one frame of reference, not in others. The notion of simultaneity is relativized in Einstein. So what we're going to say, I mean, is it postmodernists and fake truth people have really jumped onto this, saying that science is not really supplying a standard for truth. There is no truth. It's just a question of what different people can believe. Some people believe one thing, some people believe another. You can interpret the facts in either way. It doesn't. There are some people who still believe in a classical Newtonian physics. You can accommodate all the data within it. So what's going on? This is a real challenge to our view that science is a way of finding out the truth. And there's been over the centuries, but more in particular over the past several decades, various attempts to respond to that problem by philosophers of science. One is to give up on theories as truth-seeking, as being about the truth. We shouldn't think of scientific theories as even attempting to tell us what the fundamental structure of the universe is like. Because remember, theories by definition postulate some underlying reality that account for the observable reality that we see in the laboratory or when we're making observations. So Newton's theory postulates that there's this invisible, intangible force of gravity, and it's that produces, in accordance with the principles he laid down in his theory, the observable orbits of the planets, for example, or how a particular object will move in a particular field when subject to a particular force. That's one possibility. It's called instrumentalism, or its most distinguished recent proponent is a philosopher in the States called Bas van Fraassen, who calls it constructive empiricism. And the idea is that science is just about codifying the phenomena. It gets the phenomena right, so it certainly isn't arbitrary or anything, but we can't really think, we've got no reason to think that what our theories say is going on beneath the phenomena is accurate. It's just that they capture the phenomena accurately, but they don't do any more than that. And then there's been a rival to that, some people sort of stick their head in the sands and don't worry about theory change, and they still think of themselves as so-called scientific realists, that is, believing that our current theories are indeed true. But you can't really have any knowledge of the history of science. It's not just once people had recognized that on the back of Einstein's theory that there were these radical theory changes in science, they saw that earlier there had been important changes too. So, for example, Fresnel's theory of light, which was massively successful, postulates the existence of an intangible, invisible, mechanical medium that is doing the vibrating to produce the wave, or constitute the waves of light. And that was completely rejected in Maxwell's theory of electromagnetism, which just has a completely sui generis electromagnetic field. There's no underlying ether or no underlying medium. So there's been important changes right through the history of science. So if we look at that case that I just mentioned of the switch from Fresnel's theory of light, which involves this elastic solid medium to carry the light waves, compared to no medium whatsoever, just the sui generis electromagnetic field in Maxwell. Although that's a radical change, if you like, in content, in metaphysics, and in the metaphysical picture that you have of that aspect of the universe, there is in fact complete continuity in terms of the mathematical equations. The equations that Fresnel has that govern, for example, the relative intensity of light that gets, when you send a light wave at a air-to-glass interface, some of the light gets reflected, some gets refracted into the glass. The intensities of the light and the relationship to their planes of polarization, Fresnel had certain famous equations for. They're completely given you again by Maxwell. So the idea is that although we can't be sure that our scientific theories are correct in terms of their content, given what's happened in the history of science and the history of theory change in particular, that there is reason to think that we've at least captured the structure of the universe in our theories. There is something importantly progressive and truth-seeking in science, despite the fact that there have been these apparently radical changes in so-called scientific revolutions. NASA, for example, the space agency, still think of themselves as applying Newtonian theory when they calculate the rocket or projectile motions. I think that's a mistake. I think technology always applies the best available theories, and in this case they're applying Einstein's theory. But Einstein's theory itself tells you that the Newtonian predictions will be well within observational error. That is, they'll be as accurate as they could possibly need to be whenever the velocity of a body that you're looking at has a small velocity relative to the velocity of light. Basically everything in Newton, all predictions in Newton get multiplied by a factor, the square root of 1 minus v squared over c squared, where v is the velocity of the light, the velocity of the object that you're looking at, c is the velocity of light, which is of course enormous. So that quantity is very close to 1. So the predictions that you get from Newton are all bang on the money, all within any conceivable observational error bars, except when you get very, very fast-moving objects, which of course rockets are not compared to the velocity of light. So there's a very important continuity in science through scientific so-called revolutions. And so what one should look to with respect to the problem of scientific realism, what we should think of how science, fundamental theories in science relate to the truth, is we should look at the history of science and see where we do have continuity. We do have continuity with respect to mathematical structure. We don't have continuity with respect to, if you like, metaphysical image that the theories are giving us. So stick to the structure and just enjoy the metaphysical image, but don't take it too seriously.